Hello everyone, welcome to this video. In this video we are going to see what is a series. In the previous videos we have studied about sequences, right? So we define a sequence in symbols like this: A1, A2, A3, A4, A5 and so on, right? These are the members of the sequence. For using this sequence we can now define a series. The expression of this kind where we just instead of this comma we just place a plus sign everywhere, so that expression becomes our series. So basically our series is an expression where we represent that all the terms they are being added to each other, right? So this is a series which is associated with the given sequence. As for an example, consider the sequence that we have solved in the previous videos. We were given the first term a1 as 1 and the terms ahead of it. So for n is equal to 2 or greater than 2, so that means n is equal to 2, 3, 4, 5, 6 and so on. We have the value of an as equal to an minus 1 plus 2, right? So we first of all need to find the first 5 terms of this sequence, and then using those 5 terms we need to write the corresponding series, right? So we first of all calculate these 5 terms. First term is given to us, this is a1 is equal to 1. For the next term in this expression, when we substitute n is equal to 2, we would have a2 is equal to a 2 minus 1 plus 2, right? And what is a2 minus 1? It is a1. And what is the value of a1? a1 is given to be 1, so we have 1 plus 2, so the answer is 3. So this is how we obtain this term as 3. Next, for a3, what do? We need to calculate it using the term a2, right? So in this expression, if we now substitute n is equal to 3, we would have a3 is equal to a2 plus 2, right? So that means we would have a3 is equal to this term. The value of a2 we have just calculated this to be 3, so it is 3 plus 2, which is 5, right? So our a3 is 5. Similarly, we can calculate a4 and a5. The values are obtained like this: 1, 3, 5, 7 and 9. So the first 5 terms of the sequence, they are 1, 3, 5, 7 and 9, as I have explained to you in the previous video. Now using the sequence, now this sequence has 5 terms. We are taking it up to 5 terms. So for this sequence, we may write a series, right? And how we may write it? We just replace this comma with the plus sign, so that we have 1 plus 3 plus 5 plus 7 plus 9 as our series. And why I have written one more plus here and dot dot thereafter, it is because actually this is an infinite series. Why? Because we can take n as large as possible. We have stopped until here, n is equal to 5. We may take n is equal to 6, we may take n is equal to 7, 8, 9, 10 and so on. So therefore there would be more terms in this series. However, we are just taking 5 of them, right? Okay, so next, when can we say that the given series is finite or infinite? A given series is finite whenever the given sequence is finite, right? So we already know when a sequence is finite, whenever it has finite number of terms, whenever the number of terms could be counted. So for finite series, we have a1 plus a2 plus a3 plus a4. This is one of the example in which we have finite number of terms. It has 4 terms and all of them are being added to each other. So therefore this is a finite series. Another example is we may have 1 plus 3 plus 5 plus 7 plus 9 plus 11. This is also finite because it has how many terms? 6 terms within it. And moreover, if our given sequence is infinite, then the series which is created from this particular sequence is also infinite. So when does a sequence is infinite? Whenever it contains infinite number of elements within it. So that means the number of elements could not be counted here. If that is so, we when we add all the entries, when we add all the numbers, our resulting series would also be infinite in nature. For example, if we create a series from the sequence of all even numbers, you know, even numbers, they start from 2, 4, 6, 8, 10 and so 11, not 11, 10, 12, 14, 16 and so on. So when we add all of them, so I am just writing few of the elements. So 2 plus 4 plus 6 plus 8. We may write more entries as well. However, we don't know until what number we keep on doing like this. So what we do after 2-3 digits, we put dash plus dash 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 to represent that there are more terms present here in this particular series, right? As for the next example, in general form, in terms of notations, you may write it like this: a1 plus a2 plus a3 plus a4, and we keep on doing like this, plus in between there would be some term an, plus we keep on doing like this, so that we may have an infinite series, right? Another thing that should be noted here in case of series is that we may represent it in a more compact form. This compact form is just the sigma notation of the particular series. Now what is the sigma notation? In Greek, when we are using the Greek letters, this symbol over here, this one, it represents sigma. The name of the symbol is sigma, right? And we use this particular symbol in order to represent this addition. Now when we are just adding all the terms, what we can do, we can write sigma in front of this a to represent that we are adding all such a's. What such a's? Here what is changing in every term? We have 1 here, we have 2 here, we have 3 here, next 4, we have n. So this subscript here is changing. So we may write this like this. We may call this to be any number I. Now we will put a condition on I, that this I will start, I is equal to 1 for the first term. It is starting from 1 and it is going up to what number? So in case of this particular finite sequence, it is going up to 4. So I varies from 1 to 4. This is equal to a1 plus a2 plus a3 plus a4. This is about finite sequence. What about infinite sequence? For infinite sequence, we have summation ai. I varies from 1 to infinity. Why we are writing infinity? Because there are infinite number of terms. So we do not know until which term we are moving. So we start with a1. So a1 plus a2 plus a3 plus a4, and we keep on doing like this. So we put dot 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 to represent that this is a never ending series. It will go forever, right? So this is an infinite series. So this is what I have written over here. So this means summation, that means adding all the terms, right? This symbol is called sigma and the notation is called sigma notation. So therefore, if we have a series of this kind, which is a finite series consisting of n terms, the first term is a1, the last term is an, the index here is 1, the index here is n. So it is abbreviated like this: summation an, summation ak. Now instead of I, we are using k. So this could be anything. You just have to mention that what is it. Here k starts from 1 and go up to n. So this is what I have written over here. So this sigma represents we are adding all such terms. Here what is different for each term? This value k. So we have to change this k and we will start from the number 1. So k starts from 1, next value would be 2, next would be 3, next would be 4. So our answer would be a1 plus a2 plus a3 plus a4, and we keep on doing like this until we reach the last term an, right? So this is all about series. In the next videos, we'll be practicing some questions on sequence and series. Well, that is it for this video. Thank you for watching.